In this series, we're going to start looking at completing the square. Now, we're going to start off with National 5 aspects, but this will be branching out into higher as well. So for those of you that are wanting a refresher or trying to learn from scratch, this is the video for you. This is the quick method that I'm going to be teaching here. If you're more interested in why this works, I'll be doing that in a future video. Okay, so for now, what we need to look at is what kind of things point out that we are actually completing the square. So if we see a question that's written in this form, write x squared plus 4x plus 12 in the form x plus a all squared plus b. This bit here should start ringing alarm bells for you. If you see this, instantly it's completing the square. There is a very, very quick way that I do this. I just tell all my students, half it, square it, minus it. So every single time I talk about half it, square it, minus it in my classes, my pupils know that I'm talking about completing the square. To start this off though, we have to know what it is. Before we know what it is, we have to set this this function up. So we've got a pair of brackets with a squared sign outside. It has an x in it, it has a plus in it, and we've got a plus b. Now what we're going to do is just throw this plus 12 outside. So plus 12 goes on the outside. Now the it is just to begin with, this number here, plus 4. I'm told to half it. So half of positive 4 is positive 2. I'm then told to square it. That's this number this time. Square of 2 is 4. And then minus it. Just like that. All we need to do now is tidy that up. So we're going to have x plus 2 all squared minus 4 plus 12 gives you positive 8. That's it done. Okay. Second example then, we've got write x squared minus 8x plus 10 in the form x minus a all squared plus b. So again, this bit here is highlighting the fact that we are actually doing completing the square. You notice it's slightly different. This is a plus, this is a minus, but it still works in the exact same way. So again, first thing we did here was we set up the equation before we started messing around with this number here, okay? So we started off with a pair of brackets with a squared sign on the outside. The plus 10 stayed outside with an x and a minus. And it's, remember we said half it, that's this number. Half of negative 8 is negative 4. Square it gives you 16. And subtract it gives you minus 16. Tidy this all up now. We've got x minus 4 all squared minus 6. Done. Okay. Got a couple of examples for you guys to try for yourselves now. So we've got x squared plus 10x plus 4 and x squared minus 6x plus 10. Stop the video just now, work these out for yourselves, and then we'll talk over whether you've got the right answers or not. Okay, so I'm hoping that you've managed to give these a go. So again, we're going to set this up. Pair of brackets, squared, the plus 4 stays outside. The x squared, we now get an x. Half of that is positive 5. Square it, gives you 25, and subtract it. So we've got an x plus 5 all squared. Negative 25 plus 4 gives you negative 21. Part B, same idea again. Set up the pair of brackets. The squared sign goes on the outside. The plus 10 stays outside. Inside the brackets, x squared becomes x. Half of negative 6 is negative 3. Then we square it, gives us 9. And subtract it, gives us negative 9. Tidy these up. X minus 3 all squared plus 1. Okay. Now you will have noticed that these are all even numbers that we've checked out. Okay, all 4 of the examples we looked at are even numbers. So the question is, what happens if it's odd? Well, the same thing applies. So, as an example, let's have x squared plus, I don't know, let's have 7x plus 12. Why not? Whenever I'm doing these, I just make up random numbers, see if they work. If it works, fantastic. If it doesn't work, well, we've now got a learning point. So, same idea again. Set up the brackets, the squared sign, leave the plus 12 on the outside. The x squared becomes an x. Half of 7. Now, most people would be tempted to put in 3.5 here. But the problem is, how many people off the top of their head could work out 3.5 squared? That's quite challenging, and especially in an exam, this is only worth 2 marks. You don't want to be spending a huge amount of your time trying to work out 3.5 squared. But, nice little trick we can use, if this is 7, half of 7 is 7 upon 2. And if I then square this, that's just 7 squared upon 2 squared. Because remember from our indices topic, if you square any kind of fraction, it's the top over the bottom squared. Top squared over bottom squared, just like that. Remember the minus sign? Right, so we've now got x plus 7 upon 2, all squared. This is going to give us minus 49 over 4. And we're going to have to try and incorporate this plus 12 here. Now, what I do is I say this is 12 upon 1. I want to make it upon 4 because then I can gather the terms together. So I'm going to times top and bottom of this fraction here by 4. I'm going to get positive 48 upon 4. Now, because of the same denominator, I can gather the numerators together. I've got negative 49 plus 48. So the brackets don't change. Minus, because minus 49 plus 48 is negative 1. The bottom does not change at all. So the answer would be x plus 7 upon 2 all squared minus 1/4. We'll try another example just so you've had a chance to see it. Again, just make up a random number, x squared plus 5x will do this time. And let's make it negative, because we're not really negative so far. Negative, I don't know, 10. Let's see what happens. Okay. So, in brackets, the squared sign, negative 10 goes outside here. That becomes an x. Now, if half of 7 is 7 upon 2, then half of 5 is 5 upon 2, just like that. Take away this whole thing squared, so 5 squared over 2 squared. So that's going to give us x plus 5 upon 2 all squared minus 25 upon 4 minus, that's 10 upon 1, so times them both by 4 to get the same denominator. I get 40 upon 4 minus 25 minus 40 gives us minus 65 upon 4. Now, if you want to be pedantic about it, you could argue that this is going to be x plus 3.5 all squared minus 0.25. The SQA will definitely accept that. And over here, x plus 2.5 squared minus 16.25. But in the heat of an exam, especially if this is non-calculated, the last thing you want to try and do is change that into a decimal, just in case you get it wrong. I'd hate to think people lost a mark because they couldn't convert from a fraction into decimal form correctly. Okay, so as I say, that is our basic quick method of completing the square for National 5. The rest of the series we'll have one based upon negatives. We'll have a look where the coefficient of the x squared is not singular, and we'll be having looks at why it works in a future video as well. Okay, thanks.